Combatant commanders need a reliable source of fuel from the sea. For more than 25 years, military commanders have relied on the Offshore Petroleum Discharge System, or OPDS. Because of increased fuel requirements, the Navy and the Defense Logistics Agency's Defense Energy Support Center developed an entirely new OPDS system, which became operational in 2007. This new OPDS is a significant improvement over the OPDS legacy system. Military Sealift Command operates the centerpiece of the new OPDS, which is the 348-foot USNS Vice Admiral K.R. Wheeler. The new Offshore Petroleum Discharge System is a completely self-contained terminal capable of providing up to 1.7 million gallons of fuel in a 20-hour day from a distance of up to 8 miles offshore in 40-knot winds, 6-foot waves, and a 3-knot surface current. The system can be deployed and fully operational in less than 48 hours from arrival. In selecting a site for the OPDS deployment, military planners must have an understanding of how the weather and sea play a major role. Because the section of the flexible pipe closest to the beach floats during the deployment phase, the OPDS needs to be installed in an area that will not foul the waterway or the beach from other military units. Once fully installed, the flexible pipe will lay on the seabed, and while a small amount of the flexible pipe is protected with stainless steel armor, the vast majority of the flexible pipe is unprotected and may be damaged if laid on top of sharp objects such as jagged rocks, coral heads, or man-made objects. The OPDS system consists of 6 principal subsystems: the OPDS ship, the USNS Vice Admiral K.R. Wheeler, a commercial tanker or fuel barge, the flexible pipe system, lighter amphibious resupply cargo or LARC-15, the beach termination unit or BTU, and the 165-foot tender craft USNS Fast Tempo. The OPDS ship is government-owned and contract mariner operated. The ship is outfitted with 8 statute miles of flexible pipe on 5 large storage reels and 2 beach termination units. Shipboard watercraft include 2 LARC-15s, 2 12-meter workboats, and 1 8-meter rib. Other features include the bow discharge unit used to connect the flexible pipe to the ship's pumping system, and a dynamic positioning system that uses GPS and multiple thrusters to allow precision maneuvering when deploying and retrieving the pipe, as well as hold position or heading while pumping liquid cargo. USNS Wheeler carries 8 statute miles of flexible pipe on 5 hydraulically driven reels. The first 2 reels have 1.75 statute miles of flexible pipe, and each is fitted with stainless steel armor on the first 1,000 feet of pipe to protect it from sharp obstacles that may be encountered in the surf zone while beaching the pipe. There are 2 additional reels of flexible pipe, each with 1.75 statute miles. These are identical to the first 2 reels with the exception of the stainless steel armor. These first 4 reels of flexible pipe are basically interchangeable and may be used in any combination or quantity. Bear in mind that it's not necessary to use the entire pipe on the first 4 reels. One may only need to use enough flexible pipe to get into deep enough water for the tanker and USNS Wheeler to safely conduct pumping operations. The last reel of flexible pipe contains 2 dynamic riser sections that are each 2,661 feet long and are used to connect flexible pipe from any of the first 4 reels to the bow discharge unit on the Wheeler. At least one of the dynamic riser sections must be used each time the pipe is deployed. However, in circumstances requiring the additional distance, both can be connected together, end for a total of 5,322 feet. The flexible pipe reels are normally operated via wireless remote control. However, they also can be operated locally at a manual control station or remotely from the pilot house. It is important to note that during pipe deployment, flexible pipe must be floated to the beach to reduce pulling friction and prevent damage to the pipe. This is accomplished by using float buoys. The amount of pipe that must be floated will depend on how close to the beach the wheeler can get before she is constrained by her draft. The Beach Termination Unit, or BTU, is the beachside termination point of the OPDS. The BTU serves as the interface between the OPDS flexible pipe and the military user services. The BTU is equipped with a relief valve to ensure pressure does not exceed 125 psi at the outlet. The OPDS ship carries 2 BTUs, one on each of the 2 LARC 15s. Only 1 BTU is required per pipe deployment. Each BTU is fitted with 2 6-inch 150-pound flanges and 2 4-inch 150-pound flanges on the outlet side. The 2 6-inch flanges are used to connect to the user services. These flanges are typically outfitted with a 6-inch camlock fitting, but it can also be outfitted with a double or single groove Victaulic connector or a 300-pound flange adapter at the user services request. Contaminated product is handled through one of the 4-inch flanges, which is typically outfitted with a camlock quick connect fitting. The second 4-inch flange is connected to the relief valve outlet. Land-based fuel bladders are provided by the military user service. The lighter amphibious resupply cargo, or LARC 15, is the workhorse of the OPDS system. The LARC 15 is an amphibious water and land craft capable of carrying up to 15 tons of cargo. The main purpose of the LARC is to transport personnel, the BTU, excavator and other equipment to and from the beach. The LARC 15 is equipped with a hydraulic bow ramp to facilitate loading and unloading of equipment and 2 hydraulic capstans, each rated at 10 tons, used to winch the flexible pipe to the BTU site when using the LARC deployment method. The LARC 15 is also equipped with a diesel generator. The OPDS ship has 2 12-meter workboats that are used to support the operation in numerous ways. The most critical responsibility of the workboat is to tend to the seaward end of the flexible pipe and flotation collar once the OPDS ship overboards it. Additionally, the workboat is used for crew and personnel transfers, flexible pipe float buoy maintenance, and side-scan sonar deployment. The workboats are also used to tend the floating hose when the connection is made from the wheeler to the tanker. The OPDS ship has one 8-meter rib, whose primary mission is to assist in making the connection and disconnection of the flexible pipe to the bow discharge unit while the 12-meter workboat tends it. It can also be used for personnel transfers and float buoy retrieval. The OPDS comes with a 165-foot self-deployed tender vessel, the USNS Fast Tempo. The tender vessel is used primarily to assist in positioning the tanker astern of the OPDS ship during dynamic positioning pumping operation and can assist in deploying the flexible pipe. The tender vessel is also used to transport personnel and equipment and carries over 700 of the pipe flotation buoys in a 20-foot container on her aft deck. She is also outfitted with tripod weapons mounts and can double as a picket boat. The bow discharge unit, or BDU, is located on the very bow of the ship and is used to connect the flexible pipe dynamic riser to the OPDS ship's pumping system. The BDU is equipped with 2 hydraulic-driven winches that will connect the quick connect-disconnect coupling fixed to the seaward end of the flexible pipe and will lift the flexible pipe and flotation collar up from the ocean surface to the BDU. Once connected, the BDU provides a pivot point for the flexible pipe to allow the ship to rotate without exceeding the minimum bending radius of the flexible pipe. The BDU also allows the ship to quickly disconnect the flexible pipe from the ship in the event of an emergency. A camera is mounted on the BDU to allow the bridge crew to closely monitor the angle and tending direction of the flexible pipe. The BDU is equipped with a pig launcher that permits the insertion of a pig into the flow path. A pig is a foam device that passes through the flexible pipe to clean and dewater the flexible pipe. The OPDS Dynamic Positioning, or DP, is a system to automatically maintain the ship's position and heading using the Global Positioning System and the ship's own propellers and thrusters. This allows operations at sea where mooring or anchoring is not feasible due to deep water or interferences on the sea bottom. Dynamic positioning may be either absolute, in that the position is locked to a fixed point over the bottom, or relative to a moving object like another ship. One may also position the ship at a favorable angle towards wind, waves, and current, called weather vaning. Wheeler's DP system controls both main engines and rudders, as well as 4 tunnel thrusters, 2 forward and 2 aft, that can move the ship laterally, and 2 swing-down azimuth thrusters that can rotate 360 degrees and thrust in any direction. Wheeler is certified as a DP2 vessel, meaning she has complete redundancy at all levels of her DP system. Before installation of the OPDS can begin, a site survey must be conducted to identify appropriate sites for the beach termination unit, flexible pipe deployment route, and the OPDS and tanker DP site. These sites must be chosen based on the needs of both the combatant commanders and the need and limitation of the OPDS. The military operational commander selects the general location for OPDS installation. Water depths, bottom conditions, and prevailing currents must be known and within limitations prior to selection. Operational planners must be aware of local tidal conditions, wind, seas, currents, and weather conditions during the anticipated deployment period. Environmental limitations for OPDS installation and retrieval are a significant wave height of 6 feet, maximum wind of 40 knots, with a maximum current of 3 knots, and a beach gradient of no more than 1 to 300. The BTU site should be suitable for connecting to the supported services inland fuel system and above the high tide watermark. It must be accessible by road or rough terrain vehicles and have soil that permits burying the helical anchors or establishing a dead man capable of holding 48,000 pounds of tension so the flexible pipe can be pulled to the beach and then securely anchored. The BTU site establishes the point from which the OPDS ship position can be no more than 8 statute miles. The BTU must always be installed in a berm with a fuel-proof liner to contain any fuel or contaminated water spills. The berm area should be big enough to allow personnel to move around inside the enclosure while operating and maintaining the BTU. If possible, the site for the contaminated fuel bags should be nearby and below the height of the BTU. The flexible pipe route should follow as direct a line as possible from the beach termination site to the OPDS ship DP site. The seafloor must be fairly smooth, without obstructions such as coral heads, sunken craft, or deep holes. Depending upon the distance from the beach site to the dynamic positioning site, the flexible pipe can be routed around obstacles that cannot be removed. Depth of water should not exceed 200 feet. Prior to laying the pipe, the OPDS ship will conduct a detailed side scan with sonar images of the ocean bottom. One of the ship's 12-meter workboats will tow the sonar fish and run along a precisely plotted deployment route, making course corrections to the deployment route around any submerged objects, large coral heads, or deep holes in the seafloor. The OPDS DP site must be clear of obstructions that would endanger the flexible pipe riser while it is attached to the OPDS ship. Water depth should be at least greater than 10 feet below the OPDS ship and tanker's maximum draft to permit the vertical motion of the waves and not interfere with the ship's sea suctions or thrusters. The maximum water depth should not exceed 200 feet, and currents should not exceed 3 knots in the water column during actual flexible pipe deployment. Distance from the DP mooring site to the BTU site should not exceed 8 statute miles. However, keep in mind, the distance from the BTU site to the DP site must consider the possibility that the flexible pipe may be routed around obstacles in its path. Depending upon the results of the site selections, water depth, and distance from the beach, one of 3 pipe deployment methods will be chosen. The primary method is the first ashore winch method. The Lark deployment method is utilized for short pulls, while the dozer pull method is used for longer pulls. The first ashore winch method is used in deployments where the ship can get within 9,000 feet from the BTU site before being constrained by her draft. The lark deployment method is used in shorter deployments where the ship can get within 3,000 feet from the BTU site. And the dozer pull method is used in long pull deployments where the ship cannot get within 9,000 feet of the BTU site. The dozer pull method requires outside assistance because the OPDS ship does not carry any bulldozers. Once the deployment method is decided and the flexible pipe installation begins, USNS Wheeler will orient herself with her stern to the beach and will back toward the beach until constrained by her draft, which is typically about 30 feet. It is important to note that once constrained by draft, the ship will take up station using dynamic positioning and will remain there 6 to 12 hours until the flexible pipe is safely anchored to the beach at the BTU site. Tides can vary considerably in a 12-hour period, so knowledge of tide variations is extremely important. It is critical that planners understand that the USNS Wheeler's 2 swing-down azimuth thrusters add 10 feet to her draft. Wheeler draws approximately 20 feet with the swing-down thrusters retracted and 30 feet with them deployed. In water depths less than 10 meters, the Wheeler will have to retract her thrusters, which will limit the amount of wind and current she can compensate for. The first ashore winch method is employed when the OPDS ship is beyond 3,000 feet but no further than 9,000 feet from the beach. The OPDS ship will dynamically position itself directly off the beach from the proposed BTU site. Once the OPDS ship is stationary, a lark is launched and will head toward the proposed BTU site on the beach. Once the lark reaches the BTU site, the mission specialists will anchor the lark to the beach using the excavator to set the helical anchors. A 25-ton snatch block will then be secured to the stern of the lark. A line from one of the Wheeler's first ashore winches will be passed from the stern of the ship to a 12-meter workboat and taken to the beach. The first ashore line will be passed from the workboat to the beach party via line-throwing gun. Once the line is on the beach, it will be threaded through the 25-ton snatch block on the stern of the lark, then returned back to the ship by the workboat and attached to the pulling head on the flexible pipe. The flexible pipe is now ready to be pulled to the beach by hauling in on the Wheeler's first ashore winch. During pipe deployment, a float buoy is attached approximately every 20 feet to keep the pipe on the surface until it is safely on the beach. Once the flexible pipe reaches the designated